Okay, gang, this is a factoring problem. It's a difficult factoring problem. If I just simplify it for a moment, you would have recognized it right away. It's similar to saying, I'll focus this again if it comes out of focus. It's similar to saying this. So some people will actually do a substitution on this so they can, the e to the x sort of confuses them. They'll let e to the x temporarily be y so that they know how to factor this so they don't get confused. So they'll say like, oh, okay, this factors into y times y 5, 1 negative positive, right? Like they can factor it real easy when it's in this format, but this format, it's difficult to factor, right? So you have to figure out what times what makes e to the 2x. Well, if you've never seen it before, I'll just show you. It's e to the x times e to the x, because if you think about it, e to the x times e to the x, they have the same base. So that means you would add the exponents, right? If they have the same base, you add the exponent. So x plus x would give you e to the 2x, because x plus x is 2x. Okay, so it's that kind of idea. You got, it's just that the problem is difficult. If you guys had seen like an example of like a squared times a to the third, you would have known right away that I would say that's 2 plus 3, or that's a to the 5. It's just that it's an e, that it looks fancy. All right, and we'd already factored this, so let me do it again. This is a 5, 1, negative, positive. All right, so it's set equal to 0, so it's the zero product rule. If you forgot the zero product rule, that means that if I'm just trying to think of what variables I want to use. If something times something is equal to 0, then either the first thing has to equal to 0 or the second thing has to equal to 0, right? If their product's equal to 0, either the first guy's 0, the second guy's 0. So it's that idea. So we're going to say either e to the x plus 1 is equal to 0, or e to the x minus 5 is equal to 0. I love that you can play these videos again, because I say an enormous amount of stuff. I'm giving you an enormous amount of rules that you can, I'm so glad you can look at this again. All right, so remember, when you solve an exponential, you have to isolate it, right? So you got to move the 1 to the other side. So you'll subtract the 1, right? It goes to the other side. Now, I'm getting stuffed in here, so let me scoot this guy over a little bit. So if you have e to the, let me just write the line above it so I don't lose anybody. So we've isolated the e to the x. Now to solve e to the x, this is going to be a little tricky, because the e to the x function, if you recall what it looks like this. Oh, this one's actually shifted up 1 unit, so this one's actually up a little higher. So my point is that there's nothing you can add to this, which this is already positive. So something positive plus 1 will never go to 0, because or if you look at it this way, it's impossible for this function to be negative. This function is never going to have an output of a negative. So this first part is not possible. That's not solvable. So this part is not solvable. If for some reason you were trying to solve it, let me just show you, because some of you might forget that, and you're going to try to solve this, and you'll notice when you take the ln of both sides, hopefully you remember at that point that you can't put a negative or a 0 into an ln. Like, you should notice your calculator give you an error here, because if you know the log function, the domain of that is x has to be greater than 0. So this is impossible to solve. You'll notice you'll get an error, right? You'll get x, this side's x, but this left side is impossible to solve. So this part has no solution. And hopefully you recognized up here that even though the domain of the e function is all real, the range of it is y is greater than 0, right? It's going to go above here. So if the range is positive, you're not going to get out a negative. Again, you can shift these functions up or down, but for this one, it's shifted up. If something's shifted up, it's not going to have any negative y values. And again, I'm saying a lot at once, so feel free to like watch this again. All right, gang, so let's now solve the other one. And since the other one is shifted down, it is going to be solvable. Right, this graph is shifted down 5 units. I'm just moving the 5 to the other side. It shifted down 5 units, so it will, this is going to be solvable. So now I can take the ln of both sides. Right, that property number 3, you bring the x. I taught you guys in the lecture that ln of e is 1. So this is what we would call the exact answer. I know I'm writing fast. Let me just write that a little neater. This is what we call the exact answer. If you wanted to, you could approximate this in your calculator. When I make the little squiggles here, I'm saying you can approximate that. So you could put ln of 5 in your calculator, if your calculator is on. Let's see here. ln of 5. Okay, 1.609. 1.609. Okay, would be the approximate answer. So I'm not sure which way they asked it. If they asked it exact, it's this guy. If I say on the test, give the exact answer, you don't have to use your calculator. If they say an approximation, you're going to give this one. And again, this one is solvable, right? Because this graph is shifted down 5 units. And since it's shifted down 5 units, its horizontal asymptote is at -5. So it's saying, will this graph cross 0? Can this graph equal to 0? And it can, right? So that's what I'm solving for. Where, like, I'm basically solving for its x-intercept, right? You're setting this equal to 0. All right, gang, that's it on this one. You're getting no answer from this side. From this side, you're getting this one answer. So this just has one answer. All right, gang, catch you in another video. Bye-bye.